3 identify two cycles and 2 single graph, 1 graph. 2 cycles is composed by 2 gray and 2 black 8. Attributes here to the hand in order to have 2 cycles and single breakpoint graphs. Identify one special type of 2 cycles used to decrease the derivation distance and change the sequence of their genes. And this stage, if you have unsigned genes in the unsigned gene A, distributed sequence arbitrary for the remaining genes. And finally, compute the derivation distance to generate signed genes. The gene algorithm for you to the problem. The main idea of the gene algorithm consists in finding the signed versions of unsigned genes we can have the short translocation distance. This is because the signed sequence and the signed translocation sequence used up in signal versions solve the problem ignorant the signals in unsigned versions. We have an example unsigned genes A and B and the signed genes with both signals. The signed sequence is having but and whereas in buds and bud genes, represented by black lines, 1, 2, 3, 4, after 4 translocation, and we have sorting bud genes, correct? And mapping individual for using in the gene algorithm. One individual is representing the possible solutions for you to the problem. This is not a signal either positive or negative signal for weight gain in the gene inside the genome A. Here you have several colors of the proposed genetic array and put inside the genome A and B. Output number translocations to start gen A. 1 generate the initial population of assigned genes. 2 compute fitness of the initial population. And 3 represent the reproduction cycles. And the normal generation is length of assigned gene A. 4 perform the selection over 80% of the best individuals in the population and decide the best solutions found. 5 apply the crossover operation with the probability 9%. 6 apply the rotation operation with the probability 2%. 7 complete the fit of the current populations. 8 perform the replacement of A and others. 80% of the worst individuals in the current population. And the population is composed by signal versions representing individuals boot from unsigned genome A. And the size is n log n, where representing the length of unsigned genome A. Where the is fitting, where genes are positive, the next step is evaluate age individuals in the population with fitness functions. The fitness function is used to measure how good an individual is in the population. The fitness function is used in the more genetic algorithms is a linear algorithm proposed by background and to use it to calculate the translocation distance for signed genes. Then we calculate the translocation distance for individuals in the population. The distance translocation is used to give the genetic algorithm for the best solutions. And the reproduction cycles, the crossover operation take two individuals in the best, represents the best individuals in the population, partition at the same point, and combine the segments to form two descendants. and the rotation operation for which this event is altered one in one gene. The experiment where executed was hard, and randomization of groups contain 100 genes of different size. A group contain genes with n genes, for permutations in 10, 20 until 150, where 3% contain 2 and 3 chromosomes respectively. The approximate output was performed 1 once for each gene, and the genome average was performed 10 times for each gene, and the average result was taken. And finally, the average result is taken for weight group to approximation algorithm and genome algorithm. You have and we have the results of the experiment, 1 and 2 chromosomes, and when we represent the average results for approximation algorithm, and below for genome algorithm. Here, 1 and 3 chromosomes. The experiment showed that the average results to genome algorithm is over compared to the results of the approximation algorithms and approximately 200%. And the conclusion, the papers conclude the probability of inter-hierarchy of the problem. The 1.5 approximation which was implemented as a mechanism of control. This average is composed of theoretical of difficult implementation. To the best of our knowledge, this is the first implementation of these algorithms. Here we are displaying in this page. And instantly genome algorithm was closed further to the problem. Its usual features linear algorithms for translocation distance. The experiment showed that the algorithm has better solutions compared with the approximation algorithm. Here we have working words and future words. And the algorithm was important with the managed and the position rather techniques in this paper. Submitting the safety analysis by the Soncco-Álvarez. And in this work was additional biological data to the experiment generated from the genetic database. And future works, we have implemented parallel version of the genome algorithm. And implemented the 1.40 goes actual algorithm. We are going to implementation this algorithm in the first phase because this algorithm contain two solutions very difficult of the implementation. And these solutions involve approximation solutions for any complex problems. But we are investigating these problems, and we want to implement these algorithms and questions